Hi, welcome back to Byte Forever. This is another ZX81 assembly programming video. The recent one's been fairly popular. It seems like there's some need for this out there. And I find it interesting as well, just to try and get as much as you can out of a ZX81. We're doing character-based programming or games, and not high res or pseudo high res. That kind of thing is a bit beyond me at the moment. I'm tempted to learn about it, but for now it's assembly games that are more like stuff that you'd see in the 80s. And what we're looking at today is this Tetris. So I thought I'd go through the initial work that I've done, and there's basically not much yet apart from an overall outline of the game and the screen display. So this is the way I'm going to try and do this. Start off with the most basic kind of skeleton of a program that you could get with using comments to try and sort of kind of do a basic design. So we've got, at the moment, this code, when you run it, just prints out ZX81 1K Tetris, and then just loops around back to that intro title with this jump statement. So all these are comments that are essentially what we want to write as we're going forward with this. I've created a screen tetris.asm file. This is kind of extending the chessboard code we had before. So we've got 9 characters across and 23 rows, and that might not quite, well, 24 rows because it's counting from 0. I did have a go at running this, and there was some weird text printed at the bottom, so I'll just show that as well, see if we can get rid of that. The main sort of design of this is going to be initializing variables, a main game loop, which is kind of what's repeated on each update. So the intention is when you've got, so everyone knows what Tetris game is, right? So it's just, you've got blocks, different shapes like L shape, single square, like a T shape, and they'll drop from the top down to the bottom. The user's got to, the game player's got to rotate them to try and get complete lines at the bottom, and then as you get a complete line or lines, I think if you get 4 lines complete at once, that's called Tetris, I think. I seem to remember from somewhere. And when you see the game player's got to just keep going, and the game should speed up as you carry on and progress. So we've got to generate a new shape, so that's going to have to have a bit of random code in there to select one of the shapes. We've got to allow the user to input like rotate left, rotate right, and possibly also, I think, in proper in inverted commas games of Tetris, you can also press a space bar where it immediately drops the current shape down to the bottom. So there's stuff you can do on that. Scroll or move the shapes down as they're dropping down to the bottom. Detect if the line's been complete, and drop the remaining lines down. So you have to shuffle all the lines above the line that's disappearing down. Increase the score, and detect if game over condition has been met. If that's a collision between the shape entering at the top and the current top line or blocks at the top. So yeah, that's the overall outline, and it's kind of the same for most games, I think. You just have a main game loop after you initialize variables. Yeah, so we're gonna try and complete this game. It might be quite a few parts of this video, or it might be quite a bit of time till the next one, so because it's a bit more complicated. than previous games I've tried. Mainly just the logic and things like generating the shapes and scrolling them down. So yeah, this is a screen tetris.asm. And by the way, all this code will be on GitHub in the same. I think I've got a repo called ZX81 1K experiments, and yeah, this is we're gonna try and get it to run on a 1K unexpanded ZX81. So if I so I've got the same build.bat file. When you click on it, it actually builds both the games or both the programs in this directory, and then I commented out the bit that tries to run it, just runs Tetris. So you see there down at the bottom, with this code we've got some random characters appearing. I think that could be because we're writing too many rows. In fact, if just delete that one, try again, close that, just try and run it again. Yeah, so we have still got a problem down the bottom there. Just randomly delete another line. I think there is only meant to be 22 lines, and then 2 lines at the bottom are reserved for system to output stuff to. I know that caused problems in the racing game. Yeah, so still something going on down there at the bottom. That's the first bug. It's useful actually. If anyone else is trying to write some code in assembler, it's always good to. Well, I find it's good anyway. I can't just write a full game like in one sitting or however many sittings without running it or or assembling it and running it, and then the finished game pops out at the end. That's just not the way it works for me. There's a lot of kind of sort of trying things, see if it works. Just like this, really. There's obviously some problem there, and this, is doing the most simple thing. It's just printing that text out. I've just realised what that might be actually. So I increased the length of this because obviously ZX81 1K Tetris, the title, is longer than the 9 characters that we've got. So what we can do is just add some more. So how long does it need to be? Because we're trying to save memory in this all the time. So we've got 1, 2, 11, 12, 13, 14, and then that one's probably 15 characters, probably alright. 4, 8, 12, so we've got 13, 14, oops. So 5, 10, 15, so that should be enough for the first line. Could probably actually put these other lines back in now. Just see what happens. I mean, yeah, it'll probably crash if we've gone off the end of where the display is meant to be, but just close that, build it, or assemble it is the right term is. Yes, I think that's fixed that. It was just that this text was too long. So what I was saying in the previous chessboard video is, if we were to fully define the screen memory, that'd be 32 columns plus the CHR. Well, it's actually CHR 118, which is hexadecimal 76. That's like the start or end of the previous line. That character's got to be there, so it's actually 33 times 24 rows, and you've also got this one at the end as well. That would be pretty much over a quarter of, let's say 3/4 of the memory on a 1K ZX81, leaving 250 bytes for all system variables, stack, and our code as well, which is clearly next to nothing. So this is a challenge. We've got to basically trim as much down as we possibly can. I know in the 80s, the most amazing game was the 1K chess, which was a almost fully functioning chess programming one that run on the 1K ZX81. Was just amazing, and you can still play that to this day. Anyway, that's all we're going to do in this first video, really. Just a basic outline of the game, and stand by for part 2, 3, 4, and however many it takes. Okay, thanks for watching, and bye for now.